So for today's problem, we have valid palindrome. And a palindrome is just a word that's the same front and back. But in this case, we also don't care about alphanumeric characters. And we also don't care about the case of the letters. So for example, in this pretty long example, a man, a plan, a canal, Panama is a palindrome, because once we remove all of the non-alphanumeric characters, meaning characters comprised of numbers and letters, at that point, and also set it to lowercase, then it is a palindrome. And another example they give here is race a car. This one is not a palindrome because the EA, if it was race or race E car, it would be a palindrome, but this E and A are not flipped appropriately, or they're different characters. And our final example is a string with no alphanumeric characters in it. And this is a palindrome because empty string is a palindrome. They don't require any characters for it to be a palindrome. And it reads the same forward and backwards. And our constraints, the length of the string will be at least 1 and less than 2 to the 10 to the 5th power, or 2 times 10 to the 5th power, which I don't see being an issue here. And then S consists of only printable ASCII characters, which, since we're using JavaScript, it should not matter that much. It could matter if they decided to throw in some emojis in there and we decide to use the split method on them by chance. So if we did like happy face emoji dot split and we did not, or we passed an empty string in there, it would split it into its 2 UTF-16 characters that make up the emoji, and we would be iterating through those instead, which would cause an issue, but we don't have to worry about that. But even if we did, we could get around it by just using the spread operator, or splitting without the empty string to get our characters, or just not using the split method at all. And just for an example, it would be if we decided to do like happyface.split, like that. Well, actually like this. Well, I can console log this and see what it does. If I can type correctly today. So if we run this code, it's probably going to error out because of the wrong return type at the current moment. Yeah, there's a compile error. So we need to just return true so we can see what's happening. And go to the first test case. So if you look here, we're getting 2 UTF-16 strings. I'm not too sure how exactly to talk about those, but it would cause an error, or not cause an error, but cause our logic to be incorrect. Because if we had 2 emojis like this, it would have this first character and then the second character, which would, having this first character, then the second, then the first, then the second would be considered not a palindrome because it wouldn't be the same forwards and backwards. But yeah, enough on that piece, just a consideration if you decide to use that method. Some other languages will have similar limitations, but usually they are split by UTF-8, so you'll have to do something similar, or you'll just have to be aware of those limitations in your own language. But since we're using TypeScript, we don't have to worry about those different ones, just what we have. I think we've gone through that enough, so I'm gonna move on to more problem-based things. So for our test cases, I feel like these ones are a bit complicated. So if we have a character here, let's just say we want the letter A, and delete these other two test cases for now. So the letter A should return true. And I'll move this over so you don't have to worry about that. So since we're just purely returning true, that works out. And just so this can fail, let's add another test case that would fail. So if we do AB, that should fail. And it does. So a pretty simple way to pass this case. So if S0 equals S of 1, the 0th and first index, if they are equivalent, then we return true, else we return false. And let's try that, see how it's going. In this case is incorrect because we don't actually have a first character. So we could just throw it in here, s.length equals 1. That's also a true statement. And that works. And then our other use case we didn't think about, or we haven't looked into yet, or another test case, sorry, not use case, is what if this is a palindrome, but these are two different letters. So this is a palindrome, but one is a capital A and the other is a lowercase a. So in that case, it would be a palindrome according to our rules, but in here, we won't count it because we're purely checking the equality of the letters instead of insensitively checking. So in this case, we're getting a false, even though we should get a true. So we can simply say dot to lowercase on both. And in this case, we could do lowercase or uppercase. It wouldn't really matter. Oh, I spelled that wrong. Because we only care if they're the same letter, case insensitively, and not whether it's upper or lowercase. So here, this is working, but a pretty obvious case would be, what if there's more letters? We would need to iterate through all these. So if we do something like ABA, this is a palindrome, it should return true. But looking at our code, it won't return true. Because we are only checking the 0th and first index, which won't be the same. So this is incorrect at the current moment. So what we need to actually be doing is, instead of checking the first and second, or the 0th index and the first index letters, we should actually be checking the outermost characters. So let's say we don't need to iterate yet, but I will say left index, set that equal to 0, and then our right index is going to be equal to s.length minus 1. So this will be our rightmost character. So our string is 3 long. So the second index is this A right here. And the first index, or sorry, the 0th index, I'm going to mix these up all the time. I apologize for that. So this is our first character, but our 0th index. And we just need to check if the left index and the right index are equivalent. And this works. But now, since we've moved on to checking the left and right indexes, we don't need this initial check for if its length is 1, because now this left index and right index are equivalent for this case. Length is 1 minus 1 is 0, so it's the 0th index is checking if that's the same. So we don't even need that anymore. So let's try it again. And that works. It passes this case. And one thing we can't forget is only alphanumeric, or we only check alphanumeric. If there is any character that happens not to be alphanumeric, like a space, we will just ignore it and move on. But just for simplicity's sake, we're going to start with not having any of those. So at this point, this does work. But does anyone have any questions before I move on? Okay. Looks good. So this works, but once we get past 3 characters, it's not going to work anymore because we'll need to check 2 sets of characters. So let's add in a case where we check that. So let's just say ABCBA, and this will be valid. But it won't fail our case actually, so, or I don't believe so. Nope, it still passes. So let's make a failing case actually. So let's just say ABCCA, and that should fail because this B and the C are different characters. And we can simplify it a little bit by just saying ABCA, so I'm going to go with that. And this does fail. It returns true because it only checks these outer 2 characters. So to check these inner characters, we could either do it recursively or iteratively, but I prefer to do it iteratively personally. But I will make sure to explain both of them. So if we do it iteratively, we're just going to go through letter by letter. So like we check this first A and this last A, and then move in forwards, or move them both in towards the middle. And then we start checking that B and that C. But if we do it recursively, we would just check only the outer characters. And then we would call the function again, but only with the middle slice of the string. Does that make sense to everyone? Okay, so moving on for iteration. So our condition is going to be while the left index is less than the right index, it's okay if they're equal. Well, actually, it's not okay if they're equal in this case, or for what I just wrote, but I believe it would be fine if we moved it over anyway, because we could check to see if they're equal, but if they are equal, then it is the same character, so there's no point in checking. It's just a slight optimization. So let's take this piece. Instead of returning true, we will want to reverse this and return false in the case where they aren't the same. So we're going to return false, and then if these don't pass, return true. So if this is the case, if that's not the case, we're doing that. But if it is fine, they are equal, we want to take the left index and we want to move it in towards the middle. We want to increase it by 1. And then do the same with the right index, except for we are going to decrease it by 1 to move it towards the middle. So let us check this. See if this works. And it does. So this should work with a longer case. So I will try it out and just add in a arbitrarily long case, maybe. So there's A, B, C, D, E, D, C, B, A. It should work, but let's find out if it does or not. We want a true case a little bit longer, and it does work. Any questions so far? Okay, so our final requirement for this problem is to not check alphanumeric characters. And at the current moment, we will check them, and we don't want to. So the simplest thing we can do here is like space A. And this, at the current moment, will fail because it's going to value check them instead of ignoring the space. Yep, it says false. So we need to somehow check if a character is not alphanumeric. So if it isn't alphanumeric, this first character, then we will just skip it. Let's just make these variables real quick. So left character is equal to this down here. And we can finish that out and do the same here. Oh, I forgot this. Oh no, what did I do? I think I made it a lot smaller. Okay, I think that's the same. So back to here. So right character is equal to s right index dot to lowercase. So I can delete this as well. So if left character is not equal to right character, return false. So if it's not alphanumeric, this left character, we want to skip it. But we don't want to return false or anything. So how did we skip this before? We just did left index minus or plus equals 1. So we're going to do left index plus equals 1, and then just continue. Any questions about that? Okay. And then just for completeness, we're going to do the same exact thing here with the right index or right character. And we have not yet implemented this is not alphanumeric function. And there are a few different ways we could do it. But once we implement this, this should be the final solution. So we're going to take in a character, which is just a string, and then return a Boolean. Does anyone have any ideas on how we could check to see if the character is alphanumeric? And I just realized this is not alphanumeric. What I really wanted to do is alphanumeric. That's getting the back. Okay. Someone in chat said regex, and I can't read their name because it got truncated to just F. So sorry about that. But yeah, it looks like people are agreeing. So let's test with regex and see if it is the case. So let's make a regex literal that's going to test for digits 0 to 9 and then letters A to Z. Did I do the... I think I did it backwards. Yeah, I did it backwards. Yeah, there we go. And then dot test character. And that will check to see if... I hope this is the right regex because it's red, but we'll find out. And let's just console log a few cases just to make sure we're doing it correctly. So let's test A and then B and then like 2, 9, and then a different one that's not a alphanumeric character, a space. And let's say slash, 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 or just a single slash. Because we're not expecting to pass in more than one character. It shouldn't change anything though. So let us run this test case and see if it works. Or at least check these first. So it did work, both of these, but we did test the space. Let's see if the first one, so we get true for the first 4, which are all alphanumeric, and then false for the last 2. So it's looking like I wrote that regex correctly. Let's actually leave this here. For now, so we can use it later. And that's a pretty simple is alphanumeric function in my book. And I will redo this with not regex later as well, in case you get an interviewer who says, what if you don't have regex? So yeah, anyone have any questions about the solution? I'm going to run through after this, run through a simple string with it, and then move on to the other implementation of is alphanumeric. I'm not sure why that took me so long to say, but yeah, any questions? Okay, so one test case we actually don't have is checking, ignoring non-alphanumeric characters from the right. So we can pretty quickly actually add that in by just doing that. And it should pass since we did implement it for both the right and left, but it's good to check for both. And it looks good to me. So let's submit and see if I missed any test cases. It looks good to me. Our runtime is a little bit slow, most likely due to our regex. But I'm not actually sure if it's due to the regex because we only have a 1 long character that we're testing every time. Who knows? But yeah. So going back to our solution, the time complexity of this is O of n. I'm not entirely sure about the time complexity of the is alphanumeric function because I'm not too sure how the regex will work, but I assume that it's constant for checking single letter strings. So I'm just going to assume this is constant. It does not change. But for this portion, we are looping over the whole string one time. We're not going over any characters more than once. So in this case, it would be O of 1 time complexity. And we're not storing anything extra. We're storing 2 numbers, which is constant. We're not storing any extra numbers any other times. And then in the interim, we store 1 extra character, which also shouldn't change anything here, since they're ASCII characters. But even if they weren't, it wouldn't be that much different, so I would still consider that O of 1. So this is O of n time and O of 1 space. Any questions so far? Okay, then I'm just gonna go through an example case. With our code. So let's go through the string a question mark to b a, and then a string that won't be correct So let's say, or let's add another character on here. 3. Oh no, that shouldn't be correct because 2 is not alphanumeric. So let's add in one that does work. 3, 3, 7, 3, 3. So for our first test case, we're going to start here. Our left index is 0. I'm just going to write L for left index and R for right index. So while our left index is less than our right index, which pretty much just says our left index doesn't go beyond this one, like we have a non-alphanumeric character and they're equivalent, so they never overlap. And we have our left index before our right index. We don't go over any characters twice. But yeah, we start out with a left of 0 for this. We have 1, 2, 3, 4, 5. So 5 minus 1, we start out with the 4th index for the right one. So we're now pointing at these two A's for right and left. And let's make this one capital, because I did not account for that either in our test case. So our left character is A to lowercase, and the right character is also A, since it is to lowercase, or just lowercase a, I mean. And the first thing we check is if this left character is alphanumeric, or if it's not alphanumeric, and it is, so we ignore this block. Then we move on to this next one, check the same thing for the right, and it is alphanumeric, so we don't do this block. And then we check our left and right character, and if they aren't the same, we're going to return false, but they are the same. So we're going to increment our left index and decrement our right index. So we're no longer pointing at either one of these. And we have 1 and 3. Then we're going to continue on in our loop. So our left character is now question mark, and our right character is B. So first we check if the left character is not alphanumeric, and question mark is not alphanumeric. So we actually do go into this block this time. We move forward our left index by 1, and then continue on. So we move on 2. Yep, and since we continue, we go on to the next loop. So we check our left character again. We are starting out at 2, and then the next character is B. So we check both of these characters, see if they're alphanumeric, and they both are alphanumeric. So we skip this, and if they are different, which they are because 2 and B are different, then we're going to return false. So in this case, we return false. This is not a palindrome. Does that make sense for everyone? Okay. And then going towards a solution that does work, or an actual palindrome. Let's make that a little bit shorter since I think everyone gets the point. We would start at the left at 0, and then the right would be at 2. And then while our left index is more than our right index, our left character is the character at this index, so it is 3. And the other character is also 3 at the right index of 2. We check to see if they're alphanumeric, and both of them are, so we skip past here. If our left character is not our right character, we're going to return false, but it happens that they are the same. So we would skip past this, and we go on to here, increment our left and right indexes. We'll actually increment our left index and decrement the right. So they both end up being 1. And the thing I've been skipping over, which I shouldn't have been, is this condition. So instead of going on forever, our left index, we check to see if our left index is less than the right, which it is not. They're equal. So in this case, we would break out of this loop and return true. And if we had decided to set them equal here, we would check to see if this middle character is equal to itself, and if it was alphanumeric. And it happens to be the case that it is equal to itself. So we would be all the way down here, and then we would change this to a 2 and a 0, and then it would be not true that the left index is less than or equal to the right index. So it works either way, just you don't need to do that one extra check if you just set it less than. Does that make sense before I move on?
Yes, it makes sense.
Okay, cool. So one thing that I forgot about, the more brute force approach, I should have gone over. So if we look at this, or this piece specifically, instead of implementing this, what we could have done was ran some regex on our original string. So like if we had 1 question mark A, B, something like that, we could cut out all of this, like all of the non-alphanumeric characters. So we would cut out all of these. We'd have 1, remove this, make this one lowercase, A, B, and then we don't even need to worry about if they're alphanumeric or not, or the casing. We would just purely go through the whole string and check S left index and S right index. But that adds on some added time and space, because we need to store a new string. So at worst, we're storing another string that is the same length. So O of n, where n is the length of the string. And I'm not entirely sure of the time complexity of that, but it can't help. Maybe we look that up afterwards, or if anybody in the audience knows, please let me know. I'm sure it depends on your regex pattern, though. But yeah, okay. Any questions on that before I move on to the different way to do is alphanumeric? Okay, so if we didn't want to do this, we could check the code points. So we could get, I believe it's code point out here. So let's go to the MDN. Yeah, code point at. And we can get the code point from our string. And yes, I asked for the time complexity of regex, and I'm not sure. So code point at 0. Okay, so the time complexity of checking for A to Z 0 through 9 and testing one character is constant because the pattern is fixed. It doesn't depend on the length of the input. So, but what about the other one where we would replace all of the lowercase numbers, or replace any non-alphanumeric characters and turn it to lowercase? Because I know it would be an extra O of n for making the whole string lowercase, because you would just store a brand new string. So O of n time to create that string, and then O of n time or O and then space to store it, which doesn't change the time complexity much, but it does affect the space complexity. Oh, okay. And then there's a warning that information, the time complexity of the A to Z 0 through 9 testing on one character is from ChatGPT. So keep that in mind. But yeah, so we get the code point. Oh, did I delete the test cases here? I guess I did. Well, we can console log in here our returns. So is alpha numeric, and then pass in A, and then we're going to console log this code point. And do the same thing for Z to get the end of our range. And then we want to do 0 through 9 as well. I'm sure there's another way we could test without code points for the 0 through 9, or we could also write out an entire hash map of every single letter and character. But I feel like that it'd be kind of brute forcing it, but it's another way to do it if you'd like. Or maybe a set, not a hash map. You wouldn't want a hash map. You would want a hash set. So you could have a hash set of every character, alphanumeric character, and check to see if it's in that set. So if we run this code, our test cases should still be here. Yeah, they are. And we don't care about the rest of that. So 97 to 122 and 48 to 57. So we have is number is equal to if the code point is more than and equal to 48, as well as less than or equal to 57. And for now, we can just return is number, since we don't have is letter implemented. And we hope that these two here pass. And these do fail, which is fine. So these two are false, these two are true, that's good. We should also be testing a random character that is not within those ranges. So let's just test period and space. So let's change this to is letter. And we want 97 and 122 for these. 97 and 122. So if is number and is letter, Wait, actually not and, or, because that will never be true. And is letter, not is number. So if it is a number or it is a letter, then it's alphanumeric. So these should work, and it should still pass. So it looks like true, true, true. I can't see. I don't need to see the code point anymore. So let's just run that again, see if we can see any better. Yep, true, 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 false, false, false. And it passes all of our test cases. So here is a different solution for is alphanumeric without regex. Nima in chat asks if there's a difference between code point at and char code at. I am not entirely sure. Let's find out. We have char code at. It returns a non-negative integer as Unicode code point value of the character starting at the given index. It's based off of UTF-16 code point or code units, not Unicode. And it is for this UTF-16 code units, so it may return lone surrogates. So this will give us the fully Unicode code point at the given index. So in this case, no. There's no difference between them, but the difference between if we have if 4-bit, I'm gonna mess that up over and over. I keep saying 32-bit, but if we have a 4-bit character, then it will make a difference. So let's see. I'll remind me later, and I'll show you an instance where it would matter. But that's a good callback to our question over here, because I did not know that. So let's submit this, see if it's any faster. It seems to be a bit faster. Not sure if it's just a fluke though. What was our last one? 94 and 75 milliseconds, so it could have been just luck. But it does use less memory, and I found the memory to be more consistent. But it's not really... I'm not sure if that's a significant amount of memory though. Either way, this should still be O of 1, or this function itself, or O of 1 for time. But yeah, going on to code point versus char code real quick, since we have 5 more minutes. If we have, or does anyone have any questions about the problem before I move on to like a side topic? Okay. So let's write a function that gets, I'm just going to call it coolFun because I don't have a good name for it right now. And we'll pass it string. So let's do code point is equal to string dot code point at, and then let's say it's 0. And I don't have Vim mode here, so gotta copy paste. And then char code. So for char code at, and then this function is just gonna console log both of these. So if we pass something in like A, we get 97 for both. If we pass in like 4, we get 52. So there's no difference because both of these fit within 2 bits. But in the case where we have something higher in a higher register, or that doesn't fit into 2 bits, like this emoji that's made of 2 UTF-16 characters, I guess. I'm not entirely sure the terminology once again, but we pass this in, we get 1,228 or 128 512 and then 55357. So this one isn't giving us the same character because it's only looking at the UTF-16 pieces, so it'll think this is more than one character. And since we can see it better in the browser as well, if we do the base dot split, if you do it blank like this, it will return by character, split by character. But if you do it like this, it splits by the UTF-16 portions of it. So for our ASCII characters, it doesn't make a difference. But for the case where we had anything that is bigger than a UTF-16 character, we would have issues. Does that make sense? And just because we can do it, I think these would be different if we do code point. Oh wait, no, we're going charcode at. Yeah, so 0 and 1 have different char codes. And I believe they should add up to the right thing or add up to the other. Oh no, they don't. Interesting. Well, I might need to look more into that later, but we're almost at the end of the day as we have another minute left. So thanks everybody for coming, and yeah, but I will stay. Well, I guess I won't stay because I have to leave, but yeah, feel free to ask me any questions afterwards if you are interested. And I'm gonna stop the recording real quick and we can get into some more questions if anyone has any.